In the dark corners of the cosmos, there might be an object so indestructible, so extreme, and so brutal that it could actually kill our understanding of black holes. We call them gravastars. Imagine a cosmic soap bubble filled not with air, but with pure, concentrated energy. A bubble protected by a shell made of the weirdest, coldest, and most durable material allowed by the laws of physics. For decades, we believed that when a massive star dies, it has only two paths: becoming a neutron star or collapsing into a singularity, a black hole. But what if there is a third option, an option that doesn't break the laws of physics or delete information? Today, we explore the birth, the life, and the terrifying power of gravastars. Are they a theoretical fever dream, or will they change our understanding of the universe forever? To understand a gravastar, we first have to look at how a black hole is born. When a massive star runs out of fuel, its core collapses in less than a second. Gravity wins the eternal battle, crushing matter into an infinitely dense point called a singularity. But singularities are a nightmare for physicists. They are places where math stops making sense and time and space are reversed. A gravastar offers a cleaner alternative. During the collapse, instead of matter falling into an infinite point, something incredible happens. Atoms and particles are crushed so violently that they don't just disappear, they transform. They grind down into pure vacuum energy. This creates a mini-universe inside the star that wants to expand outwards. This outward pressure meets the inward crush of gravity, and like an ancient god hammering on an anvil, they forge a new kind of object, a gravastar. What does a gravastar look like? From the outside, it's a perfect, haunting sphere of darkness. A typical gravastar might be the size of a large city, yet possess the mass of 10 suns. But unlike a black hole, it has a physical surface, a shell. This shell is the coldest thing in the universe, sitting just a billionth of a degree above absolute zero. How can it be so cold? Because it isn't made of atoms. Atoms jiggle, and jiggling creates heat. The shell of a gravastar is made of a unique ultra-thin exotic matter that is so tight, stretching it by just 1 meter would require the energy of an entire supernova. It is the ultimate cosmic armor, holding back a sea of energy that wants to explode. A cosmic armor that won't bend even under the energy of a supernova. The universe is full of these impossible puzzles, and at FactoLab, we live to solve them. If you share our thirst for uncovering the secrets of the cosmos, hit that subscribe button and turn on the notification bell. By liking this video, you're helping us fuel our next deep space journey and bringing these discoveries to more curious minds like yours. Now, are you ready to look inside this bubble of pure energy? Let's find out why nothingness is actually much heavier than it looks. If the shell is weird, the interior is even weirder. The inside of a gravastar is empty. But it's not the kind of empty you're thinking of. It is a supercondensed nothingness. According to quantum physics, the vacuum of space isn't truly empty. It's an ocean of fluid energy. In our world, this fluid is thin, but inside a gravastar, it's as if the universe took a cosmic pump and compressed that vacuum ocean a billion trillion times. This interior is a perfect vacuum, yet it contains almost all the mass of the object. It's a stable stalemate. The energy wants to push out, the shell holds it in, and the gravity of the whole thing keeps it all together. It is the absolute limit of what physics can squeeze together without breaking reality. Why do scientists even care about gravastars? Why not just stick with black holes? The answer lies in a trauma that has haunted physicists like Stephen Hawking for years: the information paradox. Black holes seem to delete information from the universe. If you throw a book into a black hole, its information is gone forever. This violates the core laws of quantum mechanics. Gravastars solve this. Because they have no event horizon and no singularity, information isn't deleted, it's just converted. Your book would be ground down and its energy added to the interior vacuum. The information is still there, technically smeared across the shell. Gravastars are cleaner versions of black holes that don't break the rules of the game. If gravastars look and act like black holes from a distance, how can we tell them apart? The answer is in the music of the spheres, gravitational waves. When two black holes collide, they create a specific ripple in space-time that sounds like a deep, quick thud, like a bass drum that stops instantly. But if two gravastars collide, their physical shells should vibrate. Instead of a thud, they should sound like a gong, leaving subtle echoes behind as the shells ring through the fabric of space. Currently, our technology, like LIGO, is listening for these echoes. We haven't heard the gong yet, but as our ears get sharper, we might find that many of the black holes we've found are actually gravastars in disguise. What would happen if you fell into one? As you approach, the gravity would curve space so much that time would slow down for you. But unlike a black hole, where you might pass through an invisible horizon, here you would hit a solid wall of exotic matter. Except you wouldn't survive long enough to touch it. The gravitational tides would rip your atoms apart long before you reached the surface. Your remains would dissolve into the shell, becoming part of the vacuum energy. You wouldn't just be crushed, you would be recycled into the fundamental fluid of the universe, making the gravastar an infinitesimal bit larger. For a century, black holes were considered mathematical jokes, too absurd to be real. Today, we take pictures of them. Gravastars are currently in that absurd phase. Whether they are real or just a brilliant mathematical trick, they represent the core of why we do science, to challenge what we think is impossible and to find the limits of nature. Perhaps one day we will realize that the monsters in the sky aren't holes in reality, but beautiful, cold soap bubbles of pure energy. The universe is always weirder than we imagine, and that is exactly why we keep looking up. Thanks for watching until the end. If you want to dive deeper into the mysteries of space, don't forget to like, subscribe, and join the FactoLab family. What do you think? Is it a black hole or a gravastar? Let us know in the comments. Stay curious.